Great. As I was saying, good morning, good evening, welcome, whatever time you are on, whatever time zone you are on. We're going to have an exciting session about MCP. So, we're going to have a presentation. The content again is provided by the community uh, of Microsoft, and we're going to have hands-on presentation and we're going to learn about MCP. There are a lot of examples that I can present to you, and I'm going to be very frank. I haven't decided yet which way to go. So I'm thinking about this while I'm going to present you the actual presentation. Um, and the reason behind my decision is not yet finalized is because we have a very solid example from an actual template that lives currently in Awesome AZD, which is place where you can share a variety of templates accessible from everyone and maintained by a community. And it's also very easy to deploy as an exercise, as a hands-on, and of course as a know-how. And the other route we can take, and it's the most correct, I would say, is the actual content for the MCP protocol provided by the same repository where this presentation comes from. So I think we're going to follow that route. So allow me to close my camera. Feel free to send your messages over the chat. I will be able to respond to them. And yeah, a little bit of an intro, of course. Well, I'm Konstantinos. My short name is Kostas. Hello and welcome. I'm a professional in information technology for more than 20 years, have been almost everywhere. I have had the privilege to see technology evolving from the year 1997 until now. I'm not that old, I'm 49 years old, and in the screen you can see two links where you can follow my projects and you can keep up with a variety of innovations that I love to create in my spare time. In reality, I spend a lot of nights designing and creating these workshops uh, because I believe that the knowledge is to be shared. Uh, and like some people help me evolve without having something to gain out of their willingness to share knowledge. That's why I created especially the blog in cloudblogger.eu, and it followed the GitHub repository where you can find the code of the projects that you will find in the blog. I'm an Azure MVP in Azure integration and AI services. I pursue, you know, certifications, and I have been certified and from other providers as well. My main occupation, a job role was networking, while in 2016, 2017, I switched to cloud and development in cloud native. And in the latest 2 or 3 years, I have been working on full stack deployments with a variety of knowledges of frameworks and languages. Nice to meet you, everyone, and thank you for being here today. Uh, our agenda contains a variety of examples from a number of frameworks, as I mentioned earlier. We may see Java, we may see Python, we may see JavaScript, we may also see C Sharp. Let's have an overall look. What is MCP? How does it work? And how we can it? We are going to have an in-depth overview of the different MCP features, and we're going to proceed with a real-world scenario, the Microsoft Learn MCP server. This is a very interesting part of the presentation, and this is where we can also switch to an application that currently lives in the Microsoft community repositories, where you can utilize an MCP server through a web application. This is a little bit rare, and we're going to explain why. as we proceed learning our MCP. We're going to see the code of how to build an MCP server. Probably we're going to go with Python, but if you have a preference, please send your comments in the chat, and I will follow uh, the plurality of your choices. Uh, yes, so let's move on. First of all, we have seen a massive shift in the AI assisted coding space over the past few months. Previously, we could interact with clients like GHCP, GitHub, by asking them questions, having them help us with code completion, or even using them to help edit a file. Now things have changed. In VS Code and Visual Studio, we have agent mode. This agent mode makes Copilot even more helpful by turning into a real autonomous AI programmer. We have a coder on our side. When we ask an agent mode for assistance with something, it can plan, it can execute, it can iterate, it can provide reasoning behind its actions, and everything is done in a multi-step task. In reality, you can even see the reasoning while the agent builds the answer for your request. And it's not only about creating, something like a file or correct a part of the code or anything. It can actually create a whole project from the scratch. As soon as you provide access to your actual file system, you will see later that it needs to be allowed while the agent executes. It will be able to execute commands in PowerShell or in Linux, depending on where your IDE lives, and it will execute commands like create a directory, delete a file, rename a file, create a new file, and so on. This alone is pretty powerful, okay? But it's still missing a key piece, real-time context. How we're making sure that the agent is using. Thank you very much for uh, pointing out that audio was not working. So allow me to start over. When was the audio lost? Was it at this latest one, 2 minutes, or it's from the beginning? If you can write me in the chat, that would be very helpful. Thank you. Okay, I will assume that we lost audio in the last, let's say, 2 minutes or 3 minutes, something like that. Please write me in the chat so I will be able to, at the previous slides, at the previous slide. Okay, let me see at the previous. Okay, have we seen the agenda? The previous slide. Okay, understood. So okay, let's switch back, and I'm going to rephrase that. I don't know why we lost the audio. I'm going to keep that in mind. Okay, so what I was saying is that we have seen a massive shift in the AI assisted coding space over the past few months, right? We could interact with clients by asking them questions through the LLM, having them help us with code and completion, and even now we can edit the file. But the evolution has led to a full-blown agentic assistant where we can use it to make deployments of our own. The agent can turn into a real autonomous AI coder. Now, when we ask the agent mode for assistant with something, it can plan, execute, and iterate on a multi-step task. Okay, but this alone, while it is very powerful, it is missing a key piece. This is what we're saying. Real-time context. We need to make sure that the agent that we're using is aware about specific things. For example, uh, we need to be sure that it knows about the data that exists in our database. We need to be sure that the agent knows about our current project structure and what issues we are facing. We may ask it to run tests with natural language. It is a gap in reality between our code, the client, and the LLM, and everything else at the end of the day. And this is where MCP comes up. Okay, if we look into the developers ecosystem, we're going to see a number of solutions aiming to integrate different external tools and capabilities. Every new integration created a new extension. Right now, if we look into the VS Code extensions library, we're going to get lost. There are thousands of different extensions available for VS Code, for Visual Studio, and for different IDs as well, and this increases the need for maintenance, for security, for performance, and of course, it is difficult to scale. Let's see an example. Say we are developing an application and we want this application to connect to different data sources or services that we need to install several extensions. We need to open several web pages or build a custom solution, or if our company has a bunch of different data sources. Okay, we have static files, we have databases, we have a number of different data sources, a number of different teams, and they may all be implementing external data integrations differently. And every team has its own way, and every developer has their own way of developing. This, of course, can lead to a lot of confusion and redundancy. This is where our MCP comes in. Okay, this is where the variety of tools can be integrated into a single context protocol. Okay, and we can avoid every integration chaos by utilizing our model context protocol server and client, or in general the model context protocol framework. Okay, it is a standard. Imagine MCP as an open protocol that standardizes how applications provide context to LLMs. Okay, it's like a USB-C port, but for AI. Okay, and this is a global connector, a global integrator, of course, for code in our case. MCP servers provide a standard way or protocol to connect our LLMs with data, with tools and resources. It's a multi-phased integration. It's a multi-phased interface. There is a website, the MCP website, that describes MCP as a universal adapter for AI applications. It is the same way that a universal adapter let connect our physical devices to accessories. In the same way, MCP lets us connect AI applications to other data and tools, and this is without needing to build a custom connection to each different data source. Right? So this is quite interesting and it solves a lot of problems. Model context protocol created by Anthropic. It is adopted by the AI community and it is evolving together. For us, the important thing to remember is that model context protocol is adapting. Okay, it is evolving and this is happening right now. We have the privilege to be present and to be uh, the audience, to be I don't like the audience, to be citizens of a world where AI just started. Okay, I don't know where it will lead. There are a lot of uh, negative emotions about this technology, but I'm sure that everyone that is here with us today has other ideas in their mind, including me. AI is here to help. AI is here not to replace humanity, but to help humanity evolve. Okay. And I won't jump into the conclusion that eventually we're going to not do nothing. If we want to speak about evolution, we don't know what is the next thing that we're going to discover. So we cannot say that we know everything right now. No, we don't. There are 1,000 things that are meant to be discovered. And if we say that we have reached everything right now, we are fools. So in a fast evolving AI world, the model context protocol is an adapter that helps bring integration into a unified form, and it is evolving side by side with AI technology itself. It is a standard. Okay. Now, how MCP is composed? What are the parts of MCP, of Model Context Protocol? There are three main parts to know about when talking about MCP. We have hosts. These are the programs like VS Code, Copilot Studio, IDEs, and other AI tools that they want to access data through the MCP. Say, for example, we have a Copilot created, and this Copilot needs to access data in a SQL server. Okay, Model Context Protocol is there to help. There are clients, protocol clients that are sometimes are the same as the hosts. Okay, the the clients maintain these one-to-one connections with the servers. So a client could be a host or could be something else. It could be GitHub Copilot. It could be the endpoint, the Windows endpoint, our Windows device at the same time. And finally, we have servers. These are lightweight programs that each of them exposes specific capabilities through the standard of the model context protocol. We can build our own MCP servers, or we can use one of the many servers that are already out there. For example, we can connect directly to our database and analyze schemas, pull information from GitHub repositories, such as issues, pull requests, automate end-to-end testing with Playwright, okay? Or we can even build our own servers with several SDKs, and of course, this includes C#. This is pretty amazing because in a world where AI just evolved, just went from number zero to number one, we have already a universal connector that standardizes connectivity between different types of applications to different types of data endpoints. What I used uh, to refer to in my mind to understand better what model context protocol does is the relationship of applications and APIs, application programming interfaces. It is something quite similar. Okay. Now we can proceed with the demo, how we can set up and use MCP servers, or we can proceed with this deep dive into the MCP. So let me switch from the presentation to our hands-on environment, and then we will switch back to the presentation. Allow me a moment here to bring up my workstation with VS Code and follow the instructions. I'm going to make this a little bit bigger. I'm sorry. And I'm going to bring up the repositories where we can create our MCP. I'm going to share everything with you at the end of this presentation. So allow me to quickly find the repository where we're going to look into the first um, code. Let's do it with, I haven't seen any preferences. I asked earlier, if you didn't hear about it, whether you prefer C# or you prefer Python. If anyone has a specific preference, please write it in the chat. I'm going to use, let's do it with Python. We're going to build the Python Study Buddy app, an interactive console application that uses a custom MCP server to help developers learn Python concepts at beginner, intermediate, and expert levels. And the AI Research Learning MCP server, it is our own advanced MCP server that helps AI assistants find the latest AI ML research papers, highlight top discoveries, and create personalized study plans. So let's go to the first step. We need VS Code, Python, and Python extension. We have already been into the presentation and learned what model context protocol is and why it matters. For a more depth in the getting started guide, there is another Python demo. Again, I will share the links with you so you will be able to find everything. So let's go and start our part. Part one. I'm going to follow the instructions, so I'm going to do it right now, right here. I'm sorry, I'm in the same. So let me create a new folder. Here I'll create a new folder, MCP demo. It's fine. Select the folder. Start a new terminal. execute the first command, and we're going to need a virtual environment. Sometimes it's easier to do it step by step. In other demos that you may have been an audience with me, you may have seen me doing it already and presenting already the case. I think now it's better to do it together, let's say, in this step-by-step manner, especially for MCP. We will have time to show you a more advanced scenario, but for this type of presentation, I prefer to stay with the content provided by the community and make things easier because you are going to have a look later on your own using these links that I'm going to share with you. So you will be able to remember, bring back to your mind what we've done here and so on. So what we have done, we have installed the UV, which is a new package manager for Python. And then we created a new environment. This is the command where you create a new environment, and then we activate this environment. You can see here that we have already information within the directory that we created this MCP environment, right? It is very important to understand what's going on. And here is the script that activates the script that we run, and we have the virtual environment. What is a virtual environment? It is like a container that allows us to install different set of packages and execute code within this isolated container from the rest of the operating system. So instead of filling up my PC with different types of packages, different versions, and so on, I create this virtual environment and I can have specific packages for my specific project requirements. It is always the best practice to do that. So let's install the packages. I'm sorry, I'm missing something here. Yeah, I need to get the repository, I suppose. Yes, I need to uh, bring this directory into our uh, virtual machine. So I'm going to download it, copy, bring it over to our directory we just created, extract the contents, and extract here. Perfect. So now we have the directory available here, as you can see. So I can switch to the directory we just cloned. Perfect. And then rerun the command. This specific command requires this file. So if you do it with UV, you need this file. Okay. So let's switch back to our instructions while we are proceeding with the installation of the packages. Great. We are installing the packages and we will walk through the core concepts in the terminal. Python part 1 concepts. Let's run this. We can do both of these small demos, but let's do it. So, okay, while we wait, let me explain to you the more advanced demo that I have in mind to show you. So allow me here to open another tab. Yes, I will make it bigger and show you something that you will find really interesting. And for everyone that is looking to have, a better understanding with hands-on, uh, Awesome IZD is a place where people like me, people like you, can create solutions, end-to-end solutions, and post these solutions in this community-maintained directory. One of them is this one, which I have created. This project is an idea that I had where someone wants, with a physical language, with natural language, to request a diagram created for their Azure architecture. So this solution is quite complex, to tell you the truth, but it is very interesting on one hand to explore it, and on the other hand to make it work. So if we have time at the end of the day, I'm going to deploy this and show you how MCP is utilized in this specific project. All in all, you have a nice web interface where users ask an LLM to create an architecture document and an architecture diagram for a specific case. For example, any shop that's going to serve 1,000 clients, and we need high availability for our Azure SQL. We need specific storage accounts, and we need multi-zone deployment, and so on. So you write your requirement into the text box, and then MCP is going to facilitate the interaction between the agents. So we have also agents here. That's why it is a very interesting project. The project is creating two agents in Azure AI Foundry. The first agent gets the request from the user and creates the documentation, the architecture document. The secondary agent, due to its limitations, needs to find a way to create the diagram. How the second agent creates a diagram, and this is where MCP takes over. We're using MCP, a custom MCP service that provides the tools from diagrams. It is a package of Python where you can create diagrams via code, and GraphViz helps you visualize these icons. So the MCP service contains all the information a coder needs to be able to create diagrams. So we're using the intelligence of AI, of an LLM, and in our case, an agent from Azure AI Foundry, and the facilitator, the universal connector of MCP. So the agent knows, based on the requirements of the user, which icons needs to create in the diagram. This is a very, very interesting case. And if we have time, we're going to see it a little bit later. So let me continue with this. As our instructions say, we are able to uh, go through this lab. So we're going to move on to lab 2, understanding MCP core concepts, right? This lab teaches us the three core concepts of MCP: prompts, pre-written templates for tasks; tools, functions that can be executed; resources, which is file-like data that can be read; and a bonus where it is some link and letting the client perform an LLM call. Let's do it. Let's see here what we have. Let me bring this into your view so we can have a better visibility. Step 1, creating the server in Python. You can see here that in Python there are specific packages that are called, and they are imported with fastMCP, and it is creating the MCP concepts demo MCP server. This is the start, and this is the end of the code. In the middle, we need to add our tools, our resources, and our prompts. Step 2, we are running our MCP server in VS Code. How to configure your MCP server? We need to create a VS Code folder in our project directory, create an mcp.json file inside VS Code, and run the following configuration. This is the configuration. You can see that this specific lab is very easy to follow, and we are just executing it. No need to write anything. Everything is provided for us. How we define a prompt now in MCP? Now remember, the first line are to define what packages you are going to use and how you are creating your MCP server. In the middle, you are defining prompts, tools, and other um, um, artifacts that are going to be available from the MCP server to the clients that are going to connect here. So we are using a prompt and we are creating an artifact named learning levels, beginner, intermediate, and advanced. We are defining these levels just like we were going to define a list of tools, for example. We're using prompts in our case, and this is really amazing. How these prompts can be useful? We can have onboarding prompts with welcome prompts for users to verify setup and uh, tools, common workflows, one-shot tasks parameterized for usability, context-aware workflows with dynamically customized for the current user code base. These are the tools. I'm sorry, it'll be called here. So per chat tool selection. Manually add or remove tools by clicking the icon in chat. Mention tools in prompts. Use the sharp key to reference a tool in your prompt as needed. And so on. Resources. Now here is where our code really gets on. Resources is file-like data that can be read by clients. You can see the code here from our MCP, how resources are defined in Python. Python is really a bit more transparent and easy to understand than C Sharp. That's why I chose Python for our case. So alongside with prompts, we are able to define also resources. And we can add a resource to list all exercises. Okay. Now, how the LLM is going to utilize this MCP server, these resources that the MCP server is holding and publishing. We're going to run the server, and we're going to test it with VS Code to get the full workflow running. So let's do it. Server part2.py. Sorry. Give it a moment. Let's see how we can interact now with our MCP. Okay, this is running already. Okay, we define tools and the resources. Let me scroll down how the LLM is going to interact. Yeah, we need to switch to the other terminal. Let me see what we have here. Let me run a simple prompt to see what's going to happen. Otherwise, I will move on here. Okay, we have done the setup. Everything is as it is supposed to be. Okay, we've done this, and we've done also this. Let's run the study body. I'm going to run this file. Username level. Okay, let's run this symbol. Okay, nice. I'm going to move on from this setup. I'm not seeing any progress here, so allow me to switch to what I know to show you, which is really, really interesting. Let me close this and show you how we're going to utilize this very, very interesting exercise with our MCP. So let me create this folder, bring a new folder, open folder. Let me do this one and show you how you're going to. No, I don't want this. I'm sorry. I'm going to start from scratch in a clean environment. So, okay, open folder from this drive, new folder, repo MCP. We are going to deploy that full blown on Azure. So bear with me. You're going to be yes, very nice. So we need a terminal and we need just two commands to utilize this specific repo that is going to utilize quite a complex MCP and also agentic agents from Azure AI Foundry. So when we're dealing with Awesome AZD, the beauty of it is that you can just run these two commands. The first is this one, which is downloading the code. And I need to mention something very important here. These type of templates are written in a specific way, utilizing the Azure Developer CLI. This Azure Developer CLI allows you to run the solutions almost anywhere. So you just need to bring the repo down with AZD. You need, of course, AZD installed on your system. And then with AZD init and AZD app, you're going to just create the solution that someone else may have prepared for you, right? But the code is here, it's yours. Yes, thank you very much. Of course, we need to update something when it is a live session. Give it a moment, and I'm going to switch to the presentation for you to not wait here. Okay, while we are getting updated in our workstation here, let me download it and start the installation. Okay, very nice. This is good. I'm going to run azd app. So the first command was initialize this repository, and it asked me about a specific environment name. Okay, you need to select something unique, not something that anyone can have selected. So you can see here that in this folder it created this environment. Okay, this environment, it's going to use this name to make unique resources in our Azure subscription. Let me select my subscription. Every instruction is mentioned here, so don't worry. You don't need to remember anything. All the instructions are into the README file. Very nice. This is the complex case of an MCP server, and then we're going to see the MS Learn MCP server, which is a little bit more easy to ingest. So let's do this with AZD app. Right now, it will start a process where it's going to deploy everything on its own. You just need to select the subscription and make sure you are in the region that you want the resources deployed. I'm going to select Switzerland because there are specific regions that support AI Foundry with agents, right? And specific models. What? Oh, no, yeah, we need Docker to be running. This is also mentioned in the instructions. Nice. Give it a moment to start Docker Desktop because you need Docker to build the images. Okay, containerized services need Docker to be running in the background. It is free. You just download the service, Docker Desktop, and you leave it running in the background. What Docker does, it takes your code. If you want to have a good look here, what's going on, we have backend and frontend, right? Frontend is the presentation level. It's what we see in our application, the user interface. You'll see that in my frontend, there is a Docker file. What Docker file does? It takes all the code that lives into this directory and it creates a container image from it. This image is stored in our in Azure Container Registry, and when needed, when we need to host the application and expose it, this container registry is hosting the image in a way that we cannot understand it. We cannot look into and find our code. It is chunks of non-understandable data. We're going to see that once we build the application. But Azure Container Apps is pulling the code from Azure Container Registry, is pulling the code, and when you run your application, it reconstructs the code that you have already created. So it is a smart way to make containers of your code and break your frontend and your backend into different container images. In our case, we're going to have three different containers. The front end, which is the web user interface, the backend that executes all the commands that the user asks for. Every click, everything that the user wants is executed by the backend. And of course, the MCP service that I'm going to show you how that runs. Now that the Docker is up and running, we can start using AZD. The language of choice for infrastructure as code is Terraform here. You can use Bicep. It depends on what you like. So the infrastructure is here. Azure Developer CLI is looking into this folder where I have my environment name and my infra directory, and it will starts to deploy our code. First of all, it's going to containerize the images, and then it will start deploying everything on Azure. Let me show you also what we're going to see. So you will be able to have a very nice experience with quite an advanced MCP server. Now, if we want to move on a little bit, allow me to do that so we will be able to proceed into theory and hands-on as well. So what we have seen so far is that we create our MCP server that exposes tools, resources, prompts, a number of methods, we can say, or artifacts better. So a client that can talk the same language with the server can ingest and utilize these tools. So it invokes the tools, it queries for resources, and interpolates the prompts. The tools from the perspective of the model could be retrieve search, send a message, update DB records, send an email, and so on. These are functions that the model is able to understand. We can do that anywhere. Even in a very simple way to do it is from our VS Code. And the example could be this one, GitHub Copilot. I can ask GitHub Copilot to create a file named um, Konstantinos, and it will do it. Okay, this is the tool that controls the context here. The resources now that are application control is data exposed to the application. It could be files, it could be database records, it could be also API responses. That's why it is important to understand that in the AI world, MCP is the protocol that plays the role of an API translator between the client and the server. And of course, prompts, which are user controlled. These are could be predefined templates for AI interactions like document Q&A, transcript summary, and output as JSON. To recap what we have done so far, it is created a new project. We saw that project. We will use our own projects so you can have a better visibility on what's going on. We are going to connect to a data source and we're going to see that happening from the MCP context. So we're going to go a little bit deeper. In the context of MCP, tools are functions that LLMs can call to perform specific actions. It is basically function calling. Send an email, update to-dos, run tests, file issue for a bug. Okay, this example is quite interesting. Run a website and take a screenshot, and GitHub Copilot will do that for you. Okay, tools that are user controls, search results, GitHub repo. This is per chat tool selection for our GitHub Copilot. So when we're using GitHub Copilot, I want to show you something that will help you. We have this menu here, okay? These are the tools that are already integrated, built in into our Copilot, GitHub Copilot application or client to say it better. Apart from the tools, I have the capability to connect to a number of MCP servers that I'm going to install or make VS Code aware of through this interface or through this nice link. So to not tire you, look at the tools that are available through Azure MCP Server: ACR, AKS, AppConfig, AZD. So what's going on here? I can write through natural language a request, create a new resource group in my Azure subscription, and our client, GitHub Copilot, will look in the Azure MCP server and it will create a new resource group as requested by the user, utilizing the tools available in this specific MCP server. Okay, this is very important to understand. And that's why this is broken down into these three specific groups of artifacts, let's say here. Okay. For resources, we can expose data in a read-only fashion as URIs, client, agent, user, and we can have files, documents, database entries, and schemas, even images. How we can do this? It is very simple. This is the context. The open editor, files and folders, specific instructions, other MCP resources, even a screenshot, even source control, programmable tools, and so on. Okay. So I'm adding resources to my client to utilize it when executing specific actions or request, let's say better, from our application development perspective. Some use cases here: reduce response tokens by returning embedded resources that lets the agent pull the data. Expose the data files to user that way we provide two assets for the user to act on, not LLM context. Attach as context, reducing two lookups with specific resources attached. Be careful here. If I utilize this agent, this GitHub Copilot client, and I ask, have a look in my code and make corrections in my index HTML. If I don't add the index HTML into the context, I am pushing the client to utilize more tokens because it will spend also more time to look into my whole code base until it finds index. But if I add index here, as I'm saving a lot of time and a lot of resources from my GitHub Copilot client. The prompts, these are predefined templates for AI tasks explicitly invoked by the user. Okay, we can have static presets with placeholders and dynamically generated. We can have prompts like optimize code. We can write our own prompt. Hello, I want to build an application with blue background and four forms in black color. It will do it, and you will see it happening in front of your eyes. These prompts allow the servers to provide structured messages and instructions for interacting um, with the language models, right? Clients can discover available prompts, retrieve their contents, and provide arguments to customize them. Prompts are designed to be user controlled, meaning they are exposed from servers to clients with the intention of the user being able to explicitly select them for use. Okay. Now, some use cases from static templates to dynamically generated workflows with onboarding prompts, some welcome prompts for users to verify setup and tour the tools, up to common workflows and context-aware workflows. These are prompts that can be dynamically pulled in real-time data, such as GitHub pull requests, comments, and they are far more powerful than static templates, right? So let's move on to our uh, demo. I think it is time for us to start looking what's going on. So you can see here that the Terraform code has already built our it started building our application in Azure. And if I look into the resource groups, I should be able to identify this resource group. Remember the environment name that I provided? Here it is. And you can see here what's going on. It created a Foundry project under a Foundry resource. It created a Cosmos database because everything that's happening in this application with the MCP server, it stores the results of the MCP interaction in Cosmos DB. It creates the container registry where the front end and the back end are pushed. It creates a key vault that is a best practice for storing anything like API keys, identity, data, sensitive information that you don't need to expose. We have log analytics that comes with the containers, the container apps environment, a managed identity that is used to securely authenticate resources between each other, and a storage account. Uh, we may use it if we want to store additional resources here. Terraform is continuing to creating our resources, and let's have a look in our MCP service. Observe what I have here in this application. I have this Azure Node CSV. This is a CSV file that provides context to our MCP server to understand what type of icons are available when a user asks for a specific diagram. So our MCP server doesn't need to look anywhere but within the same directory that this CSV lives. This information is taken from diagrams, and let me show you what I mean so everyone understands what's going on here and how the diagrams at the end of the day are created. This is very important. Python, I will write here Python so you can be able to understand the diagrams as a code repository and website. So here it is with guides, docs, notes, and GitHub. So if you see here in the documentation and go to Azure, here is the same CSV that you just saw. This is the context that is provided to our MCP server to understand which icon is going to be used when a user asks for a specific solution. The LLM agent will instruct the diagram agent to create this and this and that and that. So the MCP server will be able to pull the correct icon and create it into the canvas that you will see how that is happening live. We have also this JSON file. This is very important. It is in a JSON format and um, can have all the icon families together. So it is the name, the canonical name, and the class where it belongs. And if there are any aliases, they are mentioned here. So it is a very nice helper for our MCP. And this is the MCP. This is the MCP diagrams server. Okay, observe our code. It is written in Python. We're calling the MCP server, and here are the dynamic imports of the providers. Okay, all the providers. This specific project can be enhanced to use every provider, not only Azure, for us to create diagrams. Okay, everything is here. Remember what we said earlier about tools? Here are our tools. The services, okay, compute, database, storage, etc. This is an additional smart tool that helps the agent fix the diagram code issues in case there are any errors. So here is a validator that validates the diagram because the diagram is created first as code. And this is where we are um, engaging with our code to make sure that the code is correct. So we're using this enhanced Azure validator to make sure that the code for the diagram is correct. Okay, and this is our MCP wrapper. Now, this is also important. MCP servers are not by default ready to be consumed by web apps. They are ready to be consumed by tools like Cloud, like GitHub Copilot, and so on. So if you want to create an MCP server that will be available through a web application, you need to be able to make a wrapper, an HTTP wrapper for your server and expose it either via um, STDIO, SSC streaming, or uh, yeah, these are the methods that you are able to expose your MCP server using this HTTP wrapper. You are wrapping your MCP server around an HTTP uh, bubble, let's say. Okay, so you are able to expose this also as a service that it stays within the container apps environment. And now that we have everything deployed, let me show you what happened. Let me refresh here the view and show you the container apps. So we have three container apps here. The front end, you're going to see a nice user interface, the backend, and the MCP service. This MCP service is available only to be utilized by our backend. Okay, it is not accepting traffic from anywhere rather than the container apps environment itself. So let me return to the front end. I think everything is ready right now. Yes. So you saw with three commands, we deployed a full-blown solution, and this is our solution. Let me hit the front end. Give it a moment. You need to allow it a moment to load once you deploy your services through Azure Developer CLI. Let me reheat this. So it will be able to load again and refresh. It will take a moment, don't worry. Let me also share with you the links. This is MCP for beginners. Let me share that with you. I will share it in the YouTube chat so you will be able to get it. This is the first link, MCP for beginners. This is the community content for Azure of AI MCP. And of course, I'm going to share with you the repository and another another repository with the MCP docs server. Let me also look for our MS Learn docs MCP that I'm sure that you are going to like. Let me find it. It's not this one. Okay, I will find it easier if I look into my repositories. MS Learn MCP chat. Yes, this is the repository that we are looking for. MS Learn MCP chat. Let me find it. MS Learn MCP chat. I think it's somewhere here, but I don't remember where is it. I can always download this, but I need to add some environment variables here. Anyway, let me download MCP chat. Oh, I think I know where is it. Yes, here it is. Okay, we found it. Let me open that. And let me show you what's going on here. I don't know why this is taking so much time to load. It usually doesn't need that much time to load. Front end, application URL, yes. Oh, it is failing for some reason. The Dapper, for some reason it's failing. Okay, let's see why. This is strange. Anyway, this is very strange. Anyway, I will not be discouraged by this. I'm going to show you this one. So let's open our terminal and you're going to see how we can utilize MS Learn MCP with our own web app. This is npm run dev. Yeah, where is it? MCP chat. Yes, I have everything here. Maybe VS Code needs a restart. I don't know. Let me try. Yeah, okay. Thank you very much. Let me stop and restart my VS Code. I don't know why this is failing. It's the first time I see it. It should be able to run. Maybe it's an issue in Azure. I cannot imagine anything else. Okay, let's solve this issue with our GitHub Copilot. Okay, we're going to use the agent and we're going to allow it to utilize a variety of MCP plus the Microsoft Docs MCP, which this one we're going to use it throughout this web application. I don't know why Next is failing in my Visual Studio Code. Maybe it needs some time to load. This is the first time that's happening, and I'm really frustrated with this. Anyway, solve this issue. You can see that the GitHub Copilot is going to activate MCP extensions. Since I'm using a paid version, I have the capability to select which model I prefer. I'm using GPT-5.1 codecs lately, but I'm more comfortable with Cloud Opus 4.5 for the model. Let's see why this thing is failing, which it shouldn't be failing. Okay, yeah, let's do an npm install. This is important. So you can see here, the agent is proposing to run this command npm install from the root directory. I can also allow the agent from here, okay, to run the command directly into my terminal. or I can just adopt the solution provided by our copilot directly to our terminal. What this application does, this application utilizes the MS Learn MCP server to bring results from Microsoft documentation, the whole documentation, and this is really impressive, in a tidy manner where you are able to understand the context and the format and the syntax is very human friendly, and you don't need a separate tool to connect to your MCP. Otherwise, another way to do it is by using a tool like Claude that is able to understand uh, MCP. So observe here, how can I do it? I need to utilize my tool with the MS Learn MCP connector. Okay, this chat playground is another custom connector that currently is not, uh, how can I say, it is not there. So web, let's see if Microsoft has this here. MS Learn. No, let's add Microsoft. It's a very well-known MCP server. MS Docs. No. Windows MCP. You can have an MCP server that allows your AI model to access your file system. Let me utilize the actual URL while you are seeing this application and how it is working. Yes, we needed to run npm install. I usually forget this because I assume that the repo is already there, but it is a repository. So yes, this is a local host application, right? Nice. You can see here that it got a raw text from MS Learn MCP. So here is the web app. It's not this one. I have a better one. So allow me to open it real quick. It's the MS Learn MCP chat, and I have also the environment variables to do the connectivity for us. And I'm going to get also the URL of the MS Learn MCP to see how we are utilizing an MCP server directly from a tool. So it's going to be in the pages and in the index. I want to find the MS Learn MCP URL, and it's going to be here or here. Left. Let me discover the exact URL so I don't make a mistake. MS Docs MCP server. There is also a community GitHub that you can look into. This is the URL of the MCP that you can add directly to your tool. So let me add a connector. Mm, Configure. Yeah, I need a plan in Cloud MCP. So yeah, let me do it in another way. Since we have the application here, why lose time? Since we can do it directly from our terminal. I'm sorry. Yeah, I don't know why this thing is failing. I'm really taken by surprise here, and I don't know why it doesn't want to. Okay, now it's running. Maybe it needs some time. Yeah, this is the other MCP server. It needs some time. Yeah, it needs some time to bring up all the services and make it happen. So let's do it in a step-by-step way. First of all, MS Docs MCP. Here it is. Here is an application again that is using a unique way to connect to an MCP server. The MCP server is the MS Docs MCP server. Okay, this is our application. What is the Learn MCP server or the MS Docs MCP server? Provides an interface to the Learn Knowledge service. Okay, this actually is this one, the Ask Learn. All the documentation, all the learn.microsoft.com knowledge is provided through this MCP server gateway for configurable clients, and we're using streamable HTTP and a specific trick, let's say, to make it available through a web app. And I can ask whatever I want from MS Learn. So, what are the sorry, what are the different tiers of Azure Key Vault? Now we are sending this natural language question to our model. First of all, we are correctly accessing the MCP server. The MCP server through streamable HTTP understands what's going on. But there is a big catch here. Because the MCP server itself is not built to interact in this nice, tidy way, if you ask directly, it will bring back a bunch of unstructured text. So, what we are doing here, we are sending the response, we are sending the response to our OpenAI model just to correct the whole syntax and to make it look human readable. Okay, I'm using OpenAI here, you can see it, and here it is. You are an expert assistant, synthesize helpful answer based on the provided context. So the context is the retrieved text that we got from our MCP server. Okay, I will share with you right now the link with the community of the MCP server in GitHub. There is a lot of documentation here. And here is also my solution. You will find it in the discussion space. You can, of course, use it on your own. You can make it better. I'm always open to that. So feel free to do whatever you want with the solution. So again, the unstructured text returns the first 10 answers that it will find in the MS Learn platform. It will bring them back like a bucket of water throwing it that to your face. We are implementing Azure OpenAI to create something that has value and understandable to humans text and present it here to our user interface. This is a simple case of utilizing an MCP server through a web app. This is something more complex, nevertheless. This is really complex. So, what we have here, we have a solution that created two agents in a new Azure AI Foundry project, the design agent and the diagram agent. The design agent is an agent that provides documentation based on your request. And by request, I mean design a scalable eShop web app that stores data into Azure SQL high available servers. This is a very simple request. Usually, architects will write a full-blown paragraph here for their request. I'm making it a little bit simpler for the sake of speed. So I am asking my assistant, please design a scalable eShop web application that stores data into Azure SQL high available servers and generate architecture. What is happening right now? If we go back to our backend, you will see here that if I look through the logs now, right now in real time, you can see what's happening. The backend is starting to interact with the MCP server. It tries to communicate with the agent in Azure AI Foundry, and you will see the actual thread there. And it is validating the code to create the correct diagram. The first agent that's able to work is the design document agent. This is very easy because it is just creating the document. What you need to do it from an architectural perspective. It is a very nice document that anyone can use it in production. Of course, you need to add your own look and make sure that everything is there for you. You can see here that we have added cost optimization techniques and a lot of new things. Also, this is a project that is evolving. We can save the architecture, the document, and the diagram. And here is the diagram, a very simple diagram, as you can understand. But we can make it more complex if we ask for a scalable eShop web application that stores data into Azure SQL high available servers, uses Key Vault, and has requirements for application gateway uh, inbound routing. So it's going to create a new one. So we have just saved our architecture in Cosmos DB, and we are able to look at it, export, return to it if we want to, or add a new request here. So here are our agents. Let me show you that are interacting with our custom MCP server that is hosted as a custom MCP in Azure Container Apps. So we have this diagram agent and the design agent. The design agent is this very straightforward instructions, but the diagram agent is a little bit more difficult to make it work. I have have created a very complex prompt, providing every context that it needs to know with correct corrections and so on. That's why this needs to be a little bit more fine-tuned. Now, if you look into the threads, you will see the two threads that these are created by our agents, and this is the code that our agents creating from diagrams library, and we're using GraphViz to make this a real architecture diagram, at least something to start with when you are working in your architectures to understand how that will work. Okay. Yeah. And let me also provide to you the web application directly. And I believe that time is almost up. Yeah, we lost a little bit time trying to troubleshoot, but at the end of the day, everything was okay. I'm just a little bit hasty when I'm presenting live. I'm sorry for that. We need to be patient, and this is something that I have learned. But I always forget when I'm live, so I'm sorry for some time we lost. We just needed to wait a little bit, and everything was in place as you saw. Uh, Please ping me whatever you want, whatever you don't understand, whatever you want to build, and you are falling into difficulties. I'm very open for anyone to interact with me, and I will help you. Of course, uh, having the time to do that, I do have the the will and the drive to do it. I just need to find a little bit time, but it will be a priority for me since, as I said earlier, other people have shared knowledge, have spend their time for us to evolve. So I feel that now it's my turn to do it. That's why I'm doing these sessions. That's why I also maintain that blog that I showed you earlier. And I hope you enjoyed this little workshop. I feel that this needs to be like a 3 hours workshop so we are able to see everything end to end from the little things up to the more complex ones. We made a jump from the basic understanding of MCP to a little bit more complex things. But yeah, we don't have the time in 90 minutes to explain everything. It will be another session with MCP version 5, and this time we are going to focus on C Sharp. So please register, call your friends, and I will be happy to see you and have you with me. Thank you very much, everyone, for being here and staying up to this time. I'm really honored to have you. Bye bye, everyone. Have a great night or a great day, wherever you are calling from. Thank you so much, everyone. Bye bye.